On the last video I did of the kilowatt, I kind of failed to mention exactly why we threw off the calibration on this kilowatt meter. So basically what was going on is we have our main shunt, which is inside right there, and it's basically being represented here on this little drawing that I did. So we have the neutral line coming in. It's supposed to go through the shunt and then back out to the outputs on the meter here. Well, when we had that little solder bridge up in this little point here, basically what we were doing is we were adding another resistor to this, which would in turn basically turn this into an even lower resistance than the shunt by itself was supposed to be. And as best as I could, I measured it with my multimeter, and I believe it's supposed to be 0.001 ohms for that shunt there. So then whatever current happens to be going through this shunt here, this voltage gets measured by the microcontroller. I'm sure it goes through like some amplifiers and stuff. And that's how we get our readout after it does, its calculations and all that stuff. So because this additional piece of solder was present in the circuit, it was lowering the overall resistance, as I already said. So when I removed that piece of solder, now all we had was a shunt, and because the resistance was technically a little bit higher than it was originally, now the voltage being read here was higher, and so the microcontroller in this thing basically interprets that to be a higher current, and therefore it gives you like a higher wattage measurement and all that stuff. So I kind of thought about it. I was like, man, should I just add something there and try to get it to see if I can get it somewhat accurate or at least close to what it was again? And I kind of debated on that for a while, and then viewer Malcolm Winfield suggested like sticking some wires in here to get it recalibrated again. And I thought, you know what, we already screwed it up, and we might as well have some fun with it and try to see if we can get it to somewhat at least get close to what it was. There is a way apparently that you can have this thing like automatically calibrate if you have a 110 volt power source capable of 10 amps. So you hook up like a 10 amp load to the output, and then you plug this in, you hold down the volt button here, you plug it in, and it takes you to a menu there. And I guess it was easier on some of these older units. This is a P4400.01, and there was a previous model, just the P4400. I guess it was easier, like there was actually the menus you were able to navigate with these, and with this one you can, but I don't have a way to give it 110 volts with a accurate 10 amp load or whatever right now. So we're gonna see if adding some wires here we can get this thing to at least get back to somewhere where it was. Before we do that though, we're gonna compare what we get with it now as is with several different things here. We're going to try it with this vacuum pump. We're going to try it with this projector. I got two different incandescent bulbs right here. We have a 40 watt, then we have a 60 watt halogen, and then here is a, what was this, a 5 watt or something? Yeah, like a 5 watt, the LED, the one with nothing but a resistive, or not a resistive, a capacitor dropper there. So we're going to try it with that. We're going to try it with this LED. This is a 4 watt. And this one's, it's got like the ballast electronics and everything. And then we're also going to try it with the ballasted CFL. And this one's 23 watts. These ballasted CFLs and like LEDs, they'll give you a different current consumption reading. But that's because that's like the peak current, consumption. But it's that's just like the apparent power. And once, like the power factor correction and all that stuff's like applied, then you get your reading of what they're supposed to be. So they tend to read higher than they're actually rated for. So we're going to see that as well. We're not going to get into like all the technical details about that. So what I just want to do is I'm going to make a little chart here on the sheet of the different measurements we get with all these. We're going to check out one at a time, and then we are going to put in we're going to solder in some strands of wire here, and I'm just going to probably take turns, like cutting one at a time until we get pretty close to what we're supposed to have. I'm guessing we're going to have to mostly rely on the 40 watt one here, because that's the one we actually have like initial value for of what we got with the kilowatt. But, we're going to, I don't know, maybe try to average it out or something. I'm not even sure what we're doing yet. I just thought we would have fun with this thing. The projector has a voltage range of 100 to 240 volts and a range of 3.1 to 1.4 amps depending on where the voltage lands there. So we're probably looking at over 300 watts for this one. And then the pump here just says 1/6 horsepower. So 1/6 of 746 was like 124, close to 125 or so. For the lamps, we're going to use the same setup I had last time, the screw base here, and then I'm going to clip my leads to these two or in between these two here. And we're going to get the current measurement on the meter that way. For the rest of the other equipment, I made this. I've got a plug here with the short amount of cable and then this little outlet, and I've just used wire nuts on the ground and the neutral there, and I'm going to clip the leads to these two here. Again, with this stuff, we're messing with like mains ACs. If you don't know what you're doing, don't be attempting this kind of stuff, you know, yada yada yada. The standard disclaimers apply. Voltage seems a little high, but we can see that the kilowatt meter is not too far off there. It seems to be doing okay regarding that. They're both reading right now 121. The Agilent says 121.9. The kilowatt says 121.8. So it's not like we've thrown off the voltage measurement. Okay, so we've got them both set to measure current now. And we're going to start off with the 40 watt. And let's see what we get for both. So we already kind of saw this previously, but I'm going to do it again. So Agilent meter is reading 0.334 or so, and the kilowatt 0.37. 60 watt halogen, we got 0.58 and 0.51. We're just gonna go 0.518 on that one. The 5 watt capacitive dropper LED, we've got 0.07 on the kilowatt, and we've got 0.07, 0.07 on the Agilent. 4 watt LED, we've got, this is the one with the electronic ballast. So we got 0.05 on the kilowatt, and we have 0.053 on the Agilent. Now I've got the CFL here, the 23 watt CFL, but I'm going to let this one sit for a bit because as it warms up, the value changes. So I'm just going to let it stabilize first, and then we'll get a final reading. But even so, now we can still see that this one reads considerably higher than the Agilent meter does. Alright, so it's been sitting for a while, and I think we're pretty okay now. So the kilowatts reading 0.40, and the Agilent's reading 0.356. Okay, so here we go with the projector. And so far, the only thing I've done is just plugged it in. We can see that in standby, it's pulling just a little bit over 100 milliamps. This one says 103 here, and the kilowatts reading 0.11 here. So, I mean, obviously this one doesn't get that detailed, but let's turn it on now, and we'll see what it jumps up to, and then we'll let it warm up for a bit because the lamp has to warm up, obviously. So already we've got 200 milliamps here, and now the lamp just fired up, and it's going to warm up. It's going to take a minute, so I'm just going to jump back once it's done and settled. Okay, so it's been a bit, and the kilowatt here is saying 2.06 amps. The Agilent is saying it's kind of bouncing around 1.81. It doesn't, I don't know what exactly the projector's doing, but it keeps kind of like going up and down, up and down. I'm guessing it might have something to do with like ramping up or down the fans depending on the temperature of the lamp or something. So we're just going to say 1.81. Alright, and last but not least, the vacuum pump. So I'm just going to reach over and I'm going to hit the power switch, and we'll see what this jumps up to. Okay, so it seems to be dropping a little on this side over here, so we're just going to let it stabilize. Kilowatts here is saying about 3.2. And this one's going to... Alright, so they're both still dropping a little. Okay, we'll just wait for a little bit. We'll just say 3.16, and we'll say 2.78. Alright, so here's our chart as of now. So we've got the kilowatt measurements here, and we've got our Agilent measurements here. So we're going to try to basically get these to match as close as possible to the ones here after we add in some wires to that in between those two solder pads. Alright, so slight change of plans. What I was originally going to do is take like a bunch of little strands of wire like this, and you can kind of barely see them there. Yeah. well, yeah, right there. So I was gonna take like several strands of wires and kind of like solder them across, and then, you know, kind of take turns like chopping them off like one at a time. But the problem with that is that would pretty much give us like steps basically as to the resistance that we're gonna get across here. So instead what I did is got a solid piece of copper wire and soldered it across right there. So what I'm gonna do instead is I'm gonna take a blade and slowly shave away at it until we get a desired value. And as is right now, what I'm hoping for is that when we do some of these measurements again, we're not going to go through all of them here. We're just going to try like maybe like the first few here. What I'm hoping for is to get a value smaller than what the Agilent meter was giving us. And obviously it should be way smaller than this here. But if it gives us a value that's less or lower than what we measured here, then we can slowly start shaving away at that wire until we can somehow, or you know, get somewhat close to these values here. At least that's the goal. So let's see what we can do. Okay, I've got the 40 watt installed there. Oh, I need to put this on amps. Okay, the 40 watt incandescent bulb. So we're looking at a value of less than 0.33. And it's gonna have to be 0.33 because kilowatt doesn't read any less than that. Or I mean, well, we'll see it on the Agilent here. Something of less than 0.334. And if we happen to just like land right on that, then I guess we're in pretty good shape. But let's see what happens now. So I'm going to click the switch on. It's reading 0.04. So it's reading way less than it originally was. So that means that little piece of copper wire that I put on there is really lowering the resistance of this. So now, since we are lower than what we would want to be, we're going to start shaving away at it to try to get this number to go up something close to that. So I'm going to do that, but I'm not going to record the process of shaving it off. I mean, that's pretty self-explanatory. But let's check the 60 here and see what this gives us. Obviously, it's going to be something a little bit higher maybe than that, but it's really not going to be that much higher. Okay, so here's the 60. 0.07 per the kilowatt, and the Agilent is still, it's fairly close. It says 0.518 over here, and this is 0.5142, so it's fairly close. All right, you can see I've shaved the copper wire there. Not a whole lot, but it should be enough just to see, you know, that it does make a difference when we shave that wire. I don't know, I'm starting to get the feeling that maybe this is too thick of wire. Maybe I do have to use a smaller strand and try to shave that to lower its, or to raise its resistance a little bit. But let's see how much damage this little bit did. Okay, so here's the 40 watt for test again. Oh, bridge. Okay, so now it's reading 0.05. So we see that this did go up a little bit. And this is still pretty much sitting about the same, 0.334. Alright, so slight change of plans. While I was shaving the copper, I managed to go all the way through it with the blade, and I just basically severed it, so that was kind of pointless. But as we saw, that the value that it was reading here was like way lower because that little copper wire was lowering the resistance like way too much. So instead of what I did is I did get one of those little strands of wire that I showed you a little bit ago, and I soldered that in place instead. And as we can see, it's already reading quite a bit higher, so we are going to be able to get closer to that with the little strand of wire. However, now in shaving it, I got to be like super careful not to cut across it, and we're going to see if we can get it to match as close as possible to that one here. Alright, so I had to alter the deal even further. So I had the small little strand of wire soldered here across, and even that was proving to be too low resistance, and even after I shaved it quite a bit, it still wasn't going past like 0.24 or 240 milliamps. And then I finally ended up cutting through it again. So this time what I did is I put a wire all the way around. It's a pretty long one here to, you know, try to get it, see if that would work. And if that was still a little bit lower, then I could at least like shave parts of it off to try to get it down. But with just this by itself, I think it's actually almost spot on to where it used to be. So let me show you. Okay, so I've got the 40 watt once again. Gonna Click it on here. And now we're reading 0.33, which is definitely a lot closer than it was. So let's go down the list and we'll check the rest of them and see if we're getting fairly close values to the Agilent, which hopefully we are, but we'll find out. All the results are now in, and we're getting a little bit of something odd here. So, as we noticed, the 40 watt bulb gave us, it was fairly close to what the Agilent gave us, and it was definitely a lot lower than it initially was. The 60 watt gave us a way lower value than it was, and it's actually even a little bit below this, so it looks like we could have gotten a little bit of improvement here by shaving off a little bit of the wire. And as well as the 5 watt LED here, we got 0.06, whereas the Agilent told us 0.07. So yeah, we still could have shaved off a little bit more to get this to go up a little bit higher. However, once I got to the 4 watt LED, we saw that initially we got 0.5 on the kilowatt, we got 0.053, which seems okay, sort of. I mean, but at low values, I don't think the kilowatt's very accurate anyways, so, you know, whatever. After that, with the 23 watt CFL, we noticed that we got the exact same value, which is a lot higher than the Agilent was reading. And then once I got to the projector and the pump, it's like nothing changed actually. And originally I was getting 2.08 amps on the projector here, but I was also reading about 1.82 on the Agilent meter at that point. But I also noticed that the household voltage actually dropped by about 2 volts. It was originally sitting at about close to 122 when I ran the initial tests, but then once I did this testing again, it was like closer to 120. So the projector uses a little bit more current at lower voltages, as we can kind of see here. So, but still, after a little bit, I think it went back up to about 2.0, or the voltage went up, so the amperage went up to 2.06. So same thing. And then on the pump here, the voltage also fluctuating a little bit, so the amperage is a little bit different. We see that initially we got 3.16, and now we got 3.10 on this test, but it's still significantly higher than the meter was. So what gives, I thought. So initially I thought, okay, so maybe what's happening is that at lower currents, the wire kind of has some effect on it, but as we go up to something higher like this, suddenly the wire is not really like visible to the circuit at all, and it's just saying like, like, what wire? It wasn't until I went back to look at the wire that I realized I did something really stupid. And like, what's new, right? When I did the testing here on the first few bulbs, I didn't have the cover back on. I was just testing it with this thing with the bare back like that, and I was just plugging it in. But that's a little bit unsafe, and I didn't want to risk touching anything dumb here, so I put the cover back on. Well, where I put the wire, it went right over that hole right there, and I totally did not catch this when I first did it. Turns out on the back cover here, there's these little pegs that are for basically like aligning this board to make sure that everything like stays straight. Well, that little peg just happened to go right over the wire, and it broke it. So when I was doing my testing, once I got to about this point, there was no wire in the circuit anymore. So I'm going to have to add another wire, try to get it about the same length, and redo all this testing here, which took a while to do because, like I said, for the CFL and the projector, and I'd let those warm up for a while before I checked the final reading. So I'll add another wire. Hopefully we can kind of get some similar results at the beginning here, and then if needed, we can just shave off a little bit of wire to try to get them a little bit closer and see if we can, kind of calibrate the thing and, get it working a little bit closer to what it originally was. So, yeah, I got to redo everything, and this time I got to make sure I don't break that wire in some stupid manner. You can see in that hole right there where I poked into it and the wire split. And there's the new wire. You can see that I've kind of zigzagged it a little bit. That's because you can't really wind these things or it's going to become an inductor, and we don't want that. So I also try to keep it away from that hole, prevent anything from interfering with it or breaking it in some sort of way. And I also tried to make sure that it was kept away from the big traces, because any touching, like, say, towards like the top end right there, or the bottom end, it's going to change the values a little bit, and we don't want that. So we want to try to keep it at some point where it's going to be pretty consistent, and then from there, I can like shape a little bit off the top or the bottom. They're already sort of nicked it right there, so I hope that doesn't really affect it too much. But I'm going to run through the tests again and see what I get with this one, and if needed, then maybe I'll shave off a little bit, and then we'll come back. Okay, so this round is done, and as we can see, it's actually like super close. It's really not bad. I don't know, I'm like tempted to leave it just as is. I don't think I want to modify it at all. So we see that this one here is hitting 0.33. One thing I want to mention here, this is really not like a super scientific way to test this thing. It's just, like I mentioned, quick and dirty. We're not going for like extreme accuracy. I've already, really not expecting that thing to be like super accurate. Anyways, it's just meant to be like a quick tool for checking power and all that stuff. And I kind of should have like made another column here for the Agilent. So what I was doing in most cases here is I was waiting for the Agilent to kind of hit this value that we originally measured, and then I would check and see what the kilowatt actually read. So as we can see up here, for the 40 watt we have 0.33, 60 watt we have 0.51, 5 watt LED we have 0.06, and this one here says 0.05. And now the 23 and the projector and the pump are actually a lot closer to what they should be. This little 0.365 that I wrote up here, the lamp or the Agilent was reading about that much. It would not drop back down to 0.356. So I just wrote that that's what it was at that point, and the kilowatt was reading 0.36. So really, really close. 1.82 here when the Agilent hit 1.81. And same thing here when the Agilent hit 2.78, I was getting 2.77 on the kilowatt. So yeah, I'm tempted to just leave it as is. I don't think I really want to modify anything. It should be fine for the dumb stuff we do here. So I think I'm just gonna leave it like that. I think I got really lucky with the length of that wire and the amount of resistance it provides. So for the kind of stuff that I plan on doing around here, I mean, that should be good enough. I just mostly wanted to play around and see what we could do with this thing. This wouldn't have worked if, like, say the shunt over here was already a lower resistance than what the wire and the shunt itself, would have provided. So like, say this thing was already reading lower than what it should have been, then the only thing that would have really fixed that is some like physical modification to the shunt itself here, because the shunt was technically a higher resistance than it originally was calibrated for. Adding this wire was able to sort of get us kind of back down to the level where it was originally. So I hope that was kind of informative, and I mean, it was pretty tedious. I know that I'm really kind of cutting a lot of it out. Actually, there was a lot I just didn't record because, like, testing all this stuff over and over was really tedious, especially like waiting for the CFL to warm up, waiting for the projector to warm up. That stuff took a while, so I just kind of wanted to just run through it real quick, try to get some measurements, see what we could do to improve this, and I think that did okay, even though we kind of ran into a few little hiccups of my own doing there. Thanks for watching once again. If you have any comments or anything you'd like to leave about this, leave them down below, and I'll see you guys around the bench.